Okay, because we have such a large presentation today and we want to get started right away, we are going to kick things off right away at 3 o'clock. Okay. So, just to go over a couple of administrative items before we get started today. Please remember to stay muted to minimize interruptions. Please use our Zoom chat to ask questions related to the office hours topics. Team members will be answering questions using the Zoom chat and verbally throughout the session, but we do ask that if you have a question they are answering verbally, that you still put it in the chat. That way we have record and can account for all of the questions. And if we do need to refer back or get any extra examples or information, we have a record of that and can post all of them to our Q&A, which brings us to our next point. Answers for all topic related questions received throughout the office hours will be posted after the meeting concludes, and all meeting materials will be made available in the CCSQ DNA portal after the event. It typically does take us about a week to turn that around, and just a reminder, we do have to like 508 the recording, make sure we're tracking down all of those questions and answers before we publish them and get those 508'd as well so they're compliant. um, in the meantime, though, those links that we had at the beginning of the presentation, um, these ones right here, Laura is going to be dropping those in the chat here in just a couple of minutes. So you can view any previous office hours resources or keep an eye out for those upcoming office hours dates and topics. Okay, so with that, I'm going to be passing things over to Oren, and he is going to be presenting today on Introduction to Logging and Quality Control in Databricks.
There you go. Let me just share my screen. Okay, can everyone see my screen?
Yep, looks good.
Excellent. Thanks much. Okay, so today we are going to talk mostly about logging, but we're also going to do some talking about quality control function. And we're going to talk about mostly in Python. We are going to do a bit in R also. And the reason why you need to learn this, um, you probably realize by now that logging is much different in SAS than it was in Databricks. In SAS, every time you ran something, you got a log. It was more like a text file. You could just download it pretty easily, and it was simple to read. It told you everything happens in a function. It made it easy to seek results. Databricks logs are different. On the one hand, Databricks logs, there's some output that gets shown every time you run a command. If you run like a print statement or something to actually, you run a statement that actually prints it out or something. If you don't do a print statement, you might not be able to see as much. And it's also designed to go into audit logs so that admins can see what's happening, which is great for the administrative side, less so for the programmers. So in Databricks, it's much more complicated to do logs, and we're going to talk about some strategies you can use to actually get some good logging. So we do have some goals today. The first goal is that we're going to learn how you're going to understand how workflows can be used to save logs. And then we're going to talk about how you can use DB utils to populate a text file in your S3 bucket. We're going to get an introduction to the logging module. We're going to discuss try except blocks and why those are so useful for logging. And then we're going to talk some about some QC functions that you can use to check your data. Okay, so workflows. Basically, when you create a program at first, you are creating it in a notebook. When you're creating a process, you may decide you don't want all your code to be in one notebook. Sort of like in SAS, you might not have wanted all your code for one process to be in one program because, I mean, then one person's really working on it, you can't split up into 10 because suppose you're working on something that maybe you could split into 10 programs, well, then each person can work on each one at once. And if you just have one big one, then you just have this huge program, which can be problematic. It makes QC much more difficult because then you have to look through thousands of lines of code to find something. So in SAS, basically what you did was you scheduled programs to run, and maybe what you did is you created a shell program, which would call other programs. So you may have had a program that would include like, 8 or 10 other programs, and you would have those 10 programs which have your code, and then you would just run that one shell program whenever you want to run something. Databricks has something similar with workflows where you can just create a workflow and it'll let you run tasks. And the good thing about using workflows is that Databricks saves that output for you. And that way you can use it as a record for how the program previously ran in for comparison purposes. And let's just use this as an example. Okay, so this is a workflow we created back in lesson 1, just to show how workflows work. And if we go down, you can see, I think they're only saved for a certain amount of time, which means that some of the ones I ran earlier were apparently are now gone. But I think maybe it lasts for 90 days. But basically, what we can do is we can click on this, and we can click on the task, and we can see what happens. So here I had the hello world. Here I had this that ran, and basically everything that runs in a workflow, that all gets saved for a certain amount of time. And obviously you can't keep it forever, but it lasts for, I don't know, I think it must have been either 60 or 90 days. And that way you have a record. And that way you can use this to compare things. And that's just one of the good things about having your stuff in a workflow, that you actually know what happened. And depending whatever log you have. And if you were just to run a notebook, then you would only have what happened that last time, and you wouldn't have those previous times. So if you want to have logging in mind, having your processes in a workflow is definitely a good start. Another strategy that you can use is using a DB util. And basically the idea behind this is one of the DB utils things that they have is a put method. And basically that can be used to just insert lines of text into a file. And so what you can literally do is you can just create a file somewhere, and you just literally insert lines of text into that one text file. And it's not great. I mean, it's a text file, so hard to do searches. And I mean, yeah, if you're looking for something, you literally have to use the find button to like try and find it. If you're gonna have a lot of things, this is really gonna be tough to parse. And you need to come up with a strategy to actually like contain messages to a file instead of just rain over your file each time. But it does give you something. And just to start, the first thing we're gonna do here, I'm just gonna install the PyReadStat library. I know that we were planning on moving to something else until that's set up. I need to use PyReadStat to actually convert test files um to data frames. And I'm gonna run it early because it restarts the interpreter. So I always want to have whatever I'm installing, I always have that be one of the first things I'm doing. So I have that up here. And then for the second thing, we're just going to mount a drive, and that's just where I can store stuff. So this is pointing to, yep, it's just pointing to my personal drive, and I'm going to call it p.odp. And now what we're doing here is I'm going to point to my mount, and I'm going to create a file. It's going to be called example.log. And here I have a message, and I'm literally just putting that message into a file. And if we run this, so the show is showing what's actually happening here. I'm taking that log file, I'm reading it into a Spark data frame, and here showing it. And if I go to staff, and this would also work in UFM, but UFM has a habit of kicking me out quickly, so easier to show in staff. And I go here, and voila, there is my test log message. This does have a bit of issues because suppose I were to run something like this, and what this is doing is creating a second one. I'm doing another put statement, and if I run it, the second log statement is there, but the first log statement is gone. And if we do a refresh, and we go back to example, and yeah, you can see that I overwrote what I did the first one. So that's one of the dangers about using this put method. You need to come up with a strategy to actually like concatenate your messages instead of overwriting them. And so what we can do here is this, well, we'll help us get around it. Here, what we're doing is we're creating a new message, and basically we're creating a string that's going to hold our, it's going to be blank, and we're going to add our current message to it. We're going to add, we're adding in, I think the first a million bytes. I was at 30. With the second message, I'll be at 60. So you figure every line is 30 bytes roughly. You figure we've got what, 3,000 lines? No, 30,000 lines. Pretty big files you could create doing this. And basically the idea is if something's there, I'm going to put it into existing content. Otherwise, I'm just going to pass, I'm going to do nothing. And then I take the old content, I add it to the new content, and I'm going to use this new line character so it goes on a new line. And then I run it. Yeah. And if you go here, we can see I just wrote 63 bytes out, and now we can see that both are here. And if I go here and I refresh, and I have my 2 lines. So you can use something like that to do logging. And maybe if you only have a few lines, so then maybe that makes sense. But in general, a lot of limitations by doing that. So in order to do a better way of doing logging is using the log. And that is something that was created for Python. It wasn't necessarily created for Databricks. So some of the things that run on it may not seem, it may be hard to see how it fits in how Databricks works. And it may seem like it doesn't really make so much sense. But that's because it was created for Python itself. And the idea behind the logging module is that it lets me track events that happen as my notebook runs. And it also lets me set up logging at different levels based on the importance that's described to the event. So depending on how important something is, I can put it at a certain level. And we're going to talk about that more soon. And we can dynamically change what levels of logging I want processed. So maybe when I'm creating a program, I want to see certain messages. I want to see certain debugging things. I want to see something that gives me, it gives me like all the results of everything I'm looking at. Because I'm going to make sure my stuff is running right. I want to make sure I'm getting exactly what I expect. Or maybe I'm trying to fix an error. So I might want certain messages when I'm like trying to fix an error that I wouldn't want when I'm actually just running something. So the good thing about the logging module is that I can dynamically change that. And the really cool thing is we can use logging to create a data frame that can be used to store information out of program. And that's going to be useful because once we have the stuff in the data frame, we can export it as whatever we want. More information about the logging module can be found in this link. And this takes you to the basic tutorial. There's a basic tutorial, there's an advanced tutorial, and there's a whole lot of other stuff that you can look at if you're interested. So logging levels. There are 5 logging levels that are standard. The first one is debug, and that is your detailed information. That's basically what you do when you're trying to figure out problems, or maybe when you're first creating a program. You want to make sure things are working. it's not something that you want to have that runs like every time, like once the process is set up. And then you have your second thing, those are infos, and those are confirmation that things are working as expected. And you might have that when something's working and you want to know what the result is, and you want to know that. So, like for example, you may want to use an info for suppose you're running something that shows you how many I don't know how many columns and rows a data set has. So you write an info statement that says you have 600 rows, you have 8 columns, these are the 8 columns, and so on and so forth. Your warnings are something that happens when something unexpected happens, or it's thinking of a problem in the future. You might use this like um it depends on you can use it however whatever makes sense, but maybe you might use a warning when like your data set missing something that you're expecting, or you don't get an exact match for something, or something like that. And then there are errors. Those are a more serious problem. You're not able to find a function. You might use an error like, but the data set is missing. Like you were expecting to see a data set that is such and such, and it's just not there. That's not an error per se, but it's going to cause you problems. And then critical, those are used for serious errors. That's usually used for an error that's going to cause the program to stop running. And that's just something that it's literally going to cause a break. That's when you do the critical stuff. Yeah, so like one example for a warning, it might be used to get an unexpected result that won't cause an error. So suppose I'm running a program that tries to track how many programs people are running because I want to make sure I'm monitoring system usage. So normally it's a weekday, it's 2 o'clock in the afternoon. Normally I see about 80 programs. If I see only 30 programs running, I might want to trigger a warning. If I see 200 programs running, I might want to trigger a warning to say, I'm seeing something weird. For some reason, people aren't using the stuff. I don't know why. I don't like it. We should maybe look at it. But like, I have no reason to think that the data is wrong. It's not like it's an error or critical stuff, but it is something I might want to like, monitor or something. We can also add custom levels to these 5 levels. You want to create your own stuff. The people who create the logging package, they strongly recommend against this. Their idea is that the 5 they have created should be enough for what you need. And if you have other members of your team create them, then we have to worry about an issue of consistency. Because what happens if, say, I create a level called QC, I put it at 35, but maybe my coworker creates one, and he thinks that the level is different and it should be like a 25. And just to talk about the numbers again, since I missed that, each of these levels, they get a number. So debug is 10, info 20, warning 30, error 40, critical 50. And depending on how you use the logging module, you can actually use your numeric values to see what's on that's going on. So you might say if level is greater than 30, then I want to do such and such. And if level is greater than 30, that means only error and critical will show up. And here, when we create a new custom level, we have to give it a number value also, so it knows where to put it. So here I'm putting at 35, so it's in between warning and error. And if I were to run this, then it would show all 3 of these. Okay, so we talked about levels. How do we actually build a logger? And the first thing you need to do is you need to import the logging module. And you just do that by literally putting in import logging. And then the second thing you need to do is you need to configure the basic configuration of the logger using basic config. And we're gonna go through an example of this. But basically, it can only be called once for your logger. So you can't like change it in the middle. So make sure that you configure your logger correctly because you probably don't want to be playing multiple loggers in one program, depending on what you're doing, depending on where you want to send your loggers. And some things you want to think about is the level, which we talked about. That's the severity of messages to handle. And you might want to talk about you might want to think about what messages you want for this run. Maybe if you're running something that you're very comfortable with, you want to see error messages, or you want to see critical messages. And maybe if you are creating something at the start, you want to see all messages, but you want to set the level. And then the other idea you want to do is you want to set the format. And that's going to set the format of the log messages. And the defaults are level name, and message separated by colons. But maybe you want to change that. So maybe you want to add in, like, for example, we have the code there. That's going to give me the timestamp. It's going to be the logger name. It's going to give me the severity level. It's going to give me the message. And this is only the log messages that show up in format. That's only the ones that are going to show up as logs. That can be stuff that's actually attached to the data frame, which we're going to see later. This is what's going to show up in the Databricks notebook, but it's only going to be that one. And we're going to discuss that soon. And then also there is a date format, and that just lets you set your specified date time as specify the time that stuff that's right here. And basically you can set the date time to do whatever you want. The normal daytime format, it is very detailed. I think it's down to like milliseconds. So maybe you want to just like set your own. And then your third step, once you have all that, you're going to define a name on logger using the logging module. And then once that's done, you can use logger.log to create a message. Okay, so let's go into this a bit. So here we have done our first step, and we are doing the import logging. That is step number 1. And I also added something in here. I added this line of code. The logging module was created for these Pi4j people. And apparently, if you don't set the logging level to error or higher, they send you a bunch of info messages that are meaningless. And I'm not sure why they do it, but this is just there to turn off some annoying messages that will come up about it. So it's not anything you need to know about, but it just makes your log a bit neater. Okay, and then we're just creating a few functions. So this first function, it just creates an empty data frame. And basically I give it a dictionary, and it will spit out a data frame for me. And then we have the second one. This is going to take a schema dictionary. So I have my schema as a dictionary, and it's going to spit out as a structure. Fine. Okay, so this next module is more related to configure logging. And this is going to be our step number 2 and number 3. So here what we're doing is I have this function, configure logging, and it is going to take in a level. And the default value is info. I can set it to anything I want, but I can only have it has to be in one of these 5 things. So I have this set so that I want to make sure I'm only getting a valid level. And this means that if I were to add a level, I would need to change this function. But at this point, I'm presuming I'm only using these 5. So I'm looking for one of these 5 things. If that's not what I get, I'm going to return an error, and we'll go from there. And then I know there's something wrong, and I'll just tell them there's an error. And then instead of actually causing my notebook to break, I can return that error and then just cause the program to stop running, and I'll be good there. Fine. And the next thing I'm doing is I'm setting my basic config. And what I'm doing here is first I have the level based on this, and then I'm just setting a format here. And here I'm doing the timestamp, I'm giving my level, I'm doing my message, and I'm setting my timestamp basically just as something that shows the month, the days, and the years, and it shows the minutes and seconds. And this is something you probably don't want to do in general, because in general, you probably want to find a way to set your config that you can set up as any message you want. But if you want to make sure that people are using a specific format, then this is something like this might make sense. And then I am creating my logger right here by using that logger logging statement, and then I'm returning it. Next up, we have something that is called log message, and that's going to be what's used to send the message. And again, it's a function. It is meant to be very static. It's meant to force you into having a schema in such a way, which maybe you don't want. So we're going to discuss a better way to do it later. But this is just the standard right now. And what this is doing is I'm looking again for my level. And if it's a proper level, I'm going to log the message. It's going to give me level and message. And then I'm taking that schema, which needs to be exactly what I have. And then I'm just sending a few things. I had the timestamp there, so I'm saying the timestamp is the date. I'm creating a data frame based on the schema, and then I'm just appending what I'm adding, the new stuff, to what's already there. So here is an example. In this case, I have my dictionary. It's gonna give me three things. I have my timestamp, I have my level, my message, and they're all string. Here I am creating a logger using my configure logging function. Here I'm creating this log df based on my create empty data frame function and my schema dictionary. And then here I am logging a message and I'm using that to update my data frame. And here's doing a second one. So one's at info, one is at error. And then we can show and we can run this. And that worked 5 seconds ago. And I changed, I need to run this first because I have two log messages. Excellent. Yeah. Later, I'm going to do a second log message. I use the same name. That definitely can get you into trouble, as you just saw. But anyway, you can see, so we see two things, right? So we see these messages first, and these messages are what logging sends out to the log as part of the just logging thing. So this has nothing to do with the log df stuff. That's just, yeah, that would just be the log message would print that out. And it prints it out the way we specified in configure logging, where you have month, date, year, you have the time, you have PM or AM, and then we say info, and this is an info message, it's an error message. And then this shows you what is actually in the data frame. And you can see that the date formats are a bit different. You can see that this is what the standard date format looks like. And yeah, it's a bit messier. I'm not such a fan of the times like this. And certainly I don't need seconds to go to that many decimal spots. 192750 is plenty for me, but that's what it does. And it can work. It's a text, so it doesn't really matter. And you can see we have the level, that's info, that was that. This is the message that's there. And you can see we have our data frame. Okay, we can run this. And you'll notice that we only saw one of these. You don't see the debug. And that's because I set the log level to info. So I set the log info level to info, then this debug is not going to show up there. And things do show up here, which is just one more reason why that function, I created that function just as a way of showing, basically you can have a function that works. It might not have all the functionality you might want, And this is just one more example of that. That doesn't get rid of it, even though that the log level is set to debug the info, the debug message is still showing. We're gonna fix this in a future function. So we have our data frame. It has 4 records in it, and we want to save it to a CSV. And the problem with sending data to a CSV is that you can get weird results when you send from Spark data frames to a CSV. So we need to run this function, which is basically going to take all of our CSV files. It's going to merge them all into one if there's multiple, and it's just going to create a nice CSV file for us. And now what we're doing is I have my log. You can see that my stuff is done. I want to write it. So I have my path. I want to write it to this location. I'm running this. I want to actually just show the stuff down here, what's going on. And then I have this coalesce function, and I'm going to toss it all into one CSV file. And then I'm going to run that big CSV output. And let's see what we got. So we got here, this is what we have in the data frame. And we have to go to topic 8.login CSV. We can just do a refresh here so it shows up the newest stuff. And well, topic 8 login. And yep, you can see we have a CSV file. You can see that it has everything that is in the other file. Okay. So we mentioned try and accept earlier in this lesson. And basically what a try and accept block does, it's used for exception handling when you have code that you think might just fail. And it's something that SAS doesn't have, but it is very, very useful. Basically, Databricks tries to run the stuff that is in the try part. So any code that's in the try part, it tries to run. If it succeeds, then great. Otherwise, if the code fails, it's going to go to what's in the except part, and it's going to print out what happened there. So if the code runs, if the code works perfectly, the except block doesn't run. If the try part fails, the except part does run. You can also use an else statement in this block, and this else statement runs if there are no errors in the try block. So basically, suppose I have 3 things I want to make sure run. If they all run, then statement 4, I can put that else box, and then it will only run if the first 3 things run. And if they fail for whatever reason, then the 4th thing doesn't run. And you might use this. You might use this if you expect one of those first 3 things to fail for some reason. So you have your code set up that that code that you literally expect that that first thing that you're running may actually fail. It may fail on purpose, not just by accident. Then you run those first 3 things, and then you put the 4th thing into else, and then it won't try and run. So you have that else statement, and then there's also a finally statement. And things in the finally statement, they run at the end, and they run regardless of whether there's an error or not. And so this comes in use for like logging because it runs whether or not there's an error. So it will show up. It will show up in whatever you're doing. So let's talk about an example of using the try except block. So here I have some code. I am creating a variable Bob, and Bob is equal to 5 times 2. So if this works, it's going to print Bob. And if it fails, I'm like going to just pass, and it's just going to pass over this. I'm just not going to do anything. And the pass is used just so I don't have to leave something blank. And if these 2 things work, I'm going to send this message to the log. And finally, regardless of what happens, I'm going to print out command 22 complete, and I'm going to actually show what happened. And you can see that, yeah, we can run it, why not? You can see 5 times 2 is 10. This prints Bob, and 10 goes right there. You can see that the finally is working. So command 22 complete. And then you can see that my thing showed and that also ran because these two things ran. So you can see that I have these 5 things. You can see I have a new thing. Now this shows what happens when there's an error. And here I'm trying to divide 10 by 0, and that doesn't work. So I have it 10 by 0. It's not going to print Bob because there's an error at this point. So that doesn't get to this line. And so it goes here and it tells me an error occurred division by 0. And what I could do is I could throw in a logging message here to tell me there's an error. If there was an else statement, I could put in a logging message here to tell me that things work. And if I wanted, I could add a finally statement to tell me that regardless of whether it's worked or not, command 23 is complete. And that just helps if I'm looking through the stuff I know, you know, sometimes you're doing logging stuff and you don't know exactly when something happened because you have a log message in say maybe line 20 and you have a log message in say line 255. And maybe it's just hard to know. Well, I know that something went wrong between line 20 and line 255, but where did it actually go wrong? So if I have something at the end of each command that says this command is completed, then I know that, okay, something went wrong. It went wrong between command 22 and 23. Okay. So here's a nice example of how logging might work in a program. So we're going to play some with a few functions that we need. This first function, and this is actually one of the key functions that we created. It is validate columns. And the idea behind this one is you put in a number of columns and it checks whether it's in the data frame. And you can see how this helps for QC purposes when you are first when you're first looking at a data set. You might want to use this function to make sure the columns you need are in there. And maybe you want to change this function around a little, create another function that says, I want to make sure that my data table only has these 10 fields, and if it has say an 11th field, I want to push an error because I want to make sure my data set has the fields I think it does. It only has the fields I think it does, and has any different fields, then I want to know about it. But we have that there, and that's basically just all that what this is doing. It's looking through there, looking through my columns, and basically saying if something's missing, then raise an error. Otherwise, tell me that like everything exists. Here we have another function, manipulate data frame, and this is used to manipulate data frames. You put in a data frame, and you can either choose to select columns from it or drop columns from it, or you can do some filtering. You can do a group by, you can do a sort by, you can add stuff to it. It's basically meant to test whether the data frame is there. It can manipulate it to just make sure it has what to make sure it fits the way you want it to fit. And we use that validate columns a lot here because we want to make sure again that like everything in the select columns I want to make sure actually exists, right? If everything in the drop columns I want to make sure actually exists already. Fine. So here we are creating a new long message function. And this one we do a bit different things. Instead of doing a schema dictionary, we're adding this 2 stars in the context. And basically 2 stars means I can add a whole bunch of other fields to this. So it's not just a one-to-one. I can add many things as the context. And the idea about the context is I'm going to use that to add whatever fields I want to that data frame that's storing all my log stuff. So if I wanted to say, have, I don't know, program name, command name, or like a timestamp or a message or some other things, I can put it all in here. And that means whatever the format is, I can make it, it's dynamic. It can do whatever I want. So here we have this again, just to make sure that our levels are valid. And what we're doing is we're testing right here, we're testing whether the current level of the message is less than or is less than the logger level. And basically the idea is if it is less than it, then we don't want this message going to, we don't want this message showing up in our logs. We don't want this message showing up in the data frame that's storing our log. So something like this makes sure that I only get the messages I want in the logs I'm using. And then we're taking this stuff, we're taking our message, and that's going to be one of the things we get there. We're turning that to a string, we're taking the level, we're turning that into a string, and then we're logging the message. And then basically what we're doing is we're going to take some stuff from the schema that we're using to design the stuff. Yeah, the paramlog df, that's going to be, we want to make sure that the stuff's going to match that. I basically want to make sure that all of our stuff is matching. And then I do some stuff to make sure that message and level are both in there because I want both of them to have to be in there. I want them showing up. I don't care what other things are there, but I definitely want message and level to be there. And then this is going to create stuff and it's basically going to return your data frame for you. And then here we have some more finding functions just to make these better. And these are just things I use the workbench path that just I put in some paths there so I don't have to remember them. And then to check if S3 files exist, that's something I use as one of my QC functions. And I use this to make sure that a file actually exists. Like if I expect 3 files to be there, I want to make sure they're actually there and I do some stuff in my code to check before I run stuff. Okay. So we've gone over our functions, and actually before I go any further, I actually had better run this guy again. And I want to run this because in command 17 we overwrote log message, so I want to make sure I'm using the right function. Normally you would not have 2 functions with the same name of it, same name as each other in the same notebook, or you would try not, if you had like an auto exec stuff, you would want to make sure everything is unique. I just did that here just because I just wanted to show there's just 2 log messages function. And I mean, that was really the only idea behind it. But in general, you never want to do that. So here we're checking to see whether a file exists. So first, what we're doing is we are configuring and creating a new logger. And here we're using the set level to set the level of it. So I have that there. And then I am creating a dictionary. So here what we are creating is, this is what's gonna be the log data frame dictionary. And basically we were doing 5 things. I'm doing the program, I'm doing the command, I'm doing the timestamp, the level, and the message. So basically the program, that's just the program that's running. That's going to be this right here. Possibly not necessary. I put it in there just so you don't have to wonder what's going on. Maybe you're doing a workflow and you're having these loggers, so you want to know where things broke, and maybe you have multiple programs in one logger that way because it's a workflow. So I have that just in case. This would tell you the command. I have to insert the command manually, but this would tell me, the idea is it tells me what I'm actually running. So I would, I know what I'm up to. Timestamp, that's just what time it is. Um, it'll help me figure out things later. It might help me know whether something's taking longer or shorter than usual. The level, we talked about levels, and then the message of what's happening. And so here we are creating an empty data frame. And here I am looking for a file. I'm looking for a file parse example that's set7bdat in my folder. And I'm going to see if it exists. And if it exists, I'm going to send one message at an info level. I'm going to say it was successfully found. And I'm going to say it ran as part of log the data frame. I'm going to say it's part of check if car files exist. And I'm going to send the timestamp. If it's not there, I'm going to send it as a warning. And I'm going to say the file doesn't exist. And I'm going to send more stuff. And so let's run this. And that just ran. And you can see I have my time, and yeah, my time is off by 4 hours because of just this goes on. It goes on Unix time, and Unix time, I want to say it goes on. It, I forget what time zone it's on, but it's 4 hours off of Eastern Standard Time. So that's why you're seeing that difference there. But this is when that ran, and it's printing on my info message, printing out this, and I have this running as a print statement. And maybe I might want to change this in the future and say, instead of having this go as a print statement, I may want to go as a log or not, depending on what I want to do. And here is my data frame. You can see this was added to it. Okay. What I have here is this is something that we talked about a number of times. This just takes the stats file, turns it into a Spark data frame. I'm not going to do this in detail because we've already discussed it in previous lessons. And now here we have something different, right? So here we want to take that stats file, that my cards example that we know exists, and I want it to actually go to a data frame. So here I have the stuff saved. I have this taking this file. I'm using that convert stats going to be that to TF. I'm going to send it to cards DF, and I'm going to try it. And if it works, then I'm going to have this run, and maybe this I could actually put into an else. Maybe it should go into an else because the idea is if this runs, I want this to go, but I didn't. And basically, this is going to send it to logger one. That's the logger it's going to. This is the level, and I'm saying it was migrated to a data frame. I have my program, I have my command, so I know where it ran, and then I have my timestamp. If it fails, I'm going to raise an error, and then I'm going to write that saying it says that this does not exist. And regardless of what happens, I'm going to say command number 30 complete. We can just run this, and yeah, that's there. Okay, here we're going to check to see whether expected columns exist. And there's two ways we can do this, right? So MSRP is a column in this data set, MSP is not. And you can see down here when I do MSP, it fails. But if I were to change this to MSRP, then this would check to see whether it's there. It would run. And then regardless of what happens, it's going to send me a message. It's going to send a message. This function is sort of replicates what a proc content is. And basically the idea is to take the data frame, it's going to spit out a dictionary. And basically the idea is I'm storing number records, that's going to be a count. And then I'm going to do number of columns, it's going to be how many, what columns I have. I'm going to do the schemas, I'm going to send that stuff at the field. And then I'm just going to use this from ppprint. I'm going to import ppprint. And I'm doing message one, message two, where message one gives me how many rows and columns is in the set, and then it's gonna give me this. And then the column info is gonna give me the column names and types. And then based on that, I am just logging messages. And I had one set to error, I have one set to debug. I'm not sure. I mean, this obviously shouldn't be at error. This would be at something that would probably be at info. This one should probably be at info, but I did it. I'm not going to run it now because we're getting low on time, but this shows you what it looks like. And you can see these are my log messages. It's those two. And this would give me, it gives me log messages, and that stuff would be added to the log. And if we were to do log, not, if we are going to do the log df and show the stuff, when I ran my test, I did missing columns with MSP, so you can see that here. And then this showed the error, to showed the data frame had whatever it had. We have another sucker here. This is a frequency test one. And this just looks at a frequency based on a SSI column. And you can use it for character numeric. You probably want to use it for numeric. So basically, it is going to give you your frequencies. And when it ran, it would spit out a message saying it was successful. And I'm not going to write now because, yeah, again, time issues, but you can see This is what the output looks like. You can see that I'm looking at make. I have Toyotas. That's the main one. That's a 28. That's a 27. That's a 26, 23, so on and so forth. And then here, what we do is we would take it, we would print it out, and we would save it, and it would go out to that location. And we've already done a few of these, so we're not going to do that again. Okay, that is just a thing of Python. For R, the idea is reasonably similar. Two of the most popular packages for logging are futile.logger and logger. They both work similarly, and they both work similarly to logging in Python. And you can see that what we're doing is we call this library the futile logger library. We're going to set the threshold, and I'm saying it at debug. And you can see that this would print out all the things. Here's the debug message, the info message, the warning, the error. And if I do something to say add in the percent, this is going to let me add in a variable. So I have the percent s here that brings in variable number one, percent s here that brings in variable number two, and I get this song is just 7 words long. The threshold towards this are trace, debug, info, warn, error, and fatal. They're also going to have numbers. And again, depending on what you're doing, you may want to use, depending on what you're doing, you may want to keep some, you may want to keep others. It's going to be similar to how logging works. And then and if you want more information, you can go here and I will find it for you. And then the logger, same idea as sudo logger. It's going to do something similar. It's just going to do this for you. And you'll see that here the debug didn't run because we set it higher level than debug. So that's not going to work. And if you wanted to show up, you would need to do something like the log threshold trace, and that'll give you log level is info. And if you want more information about this, you can go to either of these things. And yeah, that is a conclusion. So just for some best practices, when building notebooks in Python, you probably want to use the logging module to develop descriptive logs. And you probably don't want to like delete stuff. But the great thing about the logging module is if you set your input levels properly, you don't have to actually ever delete your logging stuff. You just keep it and you just won't have it show up, but you don't want to show it up. You'll just say, I want the level to be such and such, and all the things that are a level you don't want to see that you won't see it at. When building notebooks in R, make sure to use either logger or futile logger to build logs. I didn't take so much time to look at them, but from what I saw, they seem reasonably similar to each other. So I think if you go with either, I think you should be fine. And it's reasonably similar to logging also. And yeah, you should consider logging building an ongoing exercise. So when you're creating a program, use logging at the debug trace level to make future debugging easier. And then when it's been created, you might want to go to the info level. And then when you're more comfortable, you might go to the warning or higher level. And you want to just like build your logging ongoing. You don't want to actually delete your stuff. You just want to have it at a low level so that you don't actually see them when you don't want to see them. And yeah, after this presentation, you should understand the following. You should have a better understanding of how workflows can allow for a record of previous runs. You should have a bit of an introduction to how logging works in both Python and R. Obviously, we spent a lot more time on Python than R, but you should have a few ideas about how R works. You should have some ideas about strategies about how logging can be used in your own processes. You should understand more about try except blocks and how they can help if you're programming and logging. And we gave you a few functions that can be used to help with manipulating data frames and doing quality control stuff. Okay, and I'm sorry for rushing there at the end. I am low on time, but that is it. Do we have any questions?
It
Julie?
looks like we're in the question that was just posted about our logging notebook. A couple of people had that question, but Colton and Dan just added the resource there for attendees. So I'll also make sure that that's reflected on our Q&A. Other than that, I think all questions have been answered. Um, there is one, but I'm not sure how long. It says, can we go back to the first try, accept demo code if we have time? And I don't know if time would allow for that, but that was one that was unresolved.
I mean, we could, but what do we want to? I can go to my table of contents.
Hey, Oren. I think it's either code block number 21 or 22, around that.
Yep.
Yeah, it's just 22. It's this one, 22. Yeah, just want to clear something up because I'm not very familiar with the try except loop. So here, just for demo purposes, there is a pass in the accept clause. But usually like accept is the code that will be executed when there's a problem, right? So this is
Correct.
just yeah, so this is just demonstrating what will happen if nothing, if there are no issues.
Yeah, you're
Okay.
definitely right. I definitely should. An exception would make more sense than that block.
Ah,
I didn't
okay.
do it there, but yeah, you're right. That would have been a better strategy.
I see. Okay, well, thanks for clearing that up. That's the end of my question.
Awesome. Thank you. Okay, if there's no more
Okay.
questions, I will stop sharing.
Thanks, Oren. So before everyone drops today, I would like to administer a poll just so we can get feedback with how we're doing and how we can continue to improve our office hours experience for you. So I am going to do that now. But in the meantime, thank you so much for joining us. Please feel free to drop once you submit your poll, and we look forward to seeing you next time you join.